All right, we'll get started here. Thanks, everybody. So today's talk is going to be about governance and security in the cloud. So we're actually going to cover a few different topics and kind of start simple and work our way up there, which is basically how you can kind of approach security. It's in layers and the way you want to kind of handle things. Start at the end, start at the beginning, and kind of work your way to add more layers of security over time. But I'm Jeff Spazzetti. I'm a member of the product management team at Hortonworks, and I work on some of our cloud solutions, including Hortonworks Data Cloud and CloudBreak. And I'm joined by Srikanth Venkat, who's also a member of the product management team at Hortonworks and actually focuses on our security and governance solutions.
Hello, everyone.
All right. So today we'll kind of go through a brief introduction about how are we trying to approach at least thinking about workloads in the cloud, and how you can actually start thinking about running them, and then kind of build to how do you actually secure them and give them a security context to run in. So we'll have to give some ideas about running workloads in the cloud, thinking about ephemerality, introduce the kind of core technologies that help you think about security for Hadoop, so Ranger, Atlas, Knox. Then we'll kind of bring them together and give you an idea of how we see data lake security coming together with those ideas of ephemerality and those core technologies. We'll do some demos, give some tips, tricks, and other things, and then wrap up with some Q&A at the end. So some background here. So when we start thinking about running workloads in the cloud, one of the big things here is really thinking about the workload you want to run, actually not having it run any longer than you actually need it to. So only consume the cloud resources you want when you need them. So you have to think about workloads that are more ephemeral, which is a big difference between running more of a long-living, long-running cluster that has all the services that you need to kind of maintain there, that is multi-workload, and is kind of sharing all the resources. But in the cloud, because the infrastructure is so agile and so flexible, you can actually think about doing purpose-built workloads, running them, processing when you want, and use cloud resources only when you're doing the work, give them back when you're done. So ephemerality is a real key thing to think about when you're doing just cloud workload processing, which also means if your workloads are coming and going, where's the data going to be? So a big thing here is thinking about really good integration with cloud storage. So the idea of Amazon S3, Azure ADLS, or Azure WASB, the idea that your data is living in there and it's durable, and your workloads come and go and do the processing on it. So putting those two things together is really kind of a way to approach workloads in the cloud. So that's great for the processing side of things, but we're going to try to think about how you actually tie security into these concepts, because the workloads are coming and going, and the storage is always there. How do we bring security together? But before we get to that, I want to at least give you an idea of how ephemeral workloads and cloud storage can come together by doing a real brief demo of Hortonworks Data Cloud. So the idea is this product that's out there is really around giving you prescriptive, ephemeral type workloads that you can spin up for Hive and Spark. You can do the work, a tight integration with S3, so you can kind of have all your data living in S3, do your Hive processing, do your Spark processing on demand, spin them down when you're done, and kind of go that way. It's pre-configured and pre-tuned to run in the Amazon environment and work with S3, and you can really try it out. But a real quick demo to show and set the stage of how we're looking at ephemeral processing with this product here. So I'll switch over. There we go. So what I actually have done here is I'm showing you Hortonworks Data Cloud. I've actually spun up 2 workloads already, but I'll tell you how I kind of got there. But at the highest level here, I've spun up a workload that exposes Hive LLAP for kind of interactive query type processing. I've spun up a workload for Spark processing with Zeppelin so I can do some data science. And the idea is that Hortonworks Data Cloud gives you a way to say, really what I want is to go and get a workload around this type of purpose-built processing. Be data science, be interactive analytics, be ETL processing, even try some newer technologies like Druid to see how that works for you. And the choice is about saying, let me go and choose the workload I want to run, and then actually go and spin it up for me, do some work, and when you're done, spin it down. So it's meant to kind of not give you the infinite choices that you usually see with any one of these types of workloads, but actually be a little bit more prescriptive so you just get the workload, spin it up when you want, and then turn it down when you're done. It also supports the idea of being able to scale itself. So even after you spin up a workload, if it's doing processing and it's realizing it needs some more resources, you can actually set up some scaling rules to say, hey, if it looks like it's starting to need more memory or more CPU, let me give it a little bit more of the cloud resources that are available so I can add them into the cluster so it can start leveraging those. And when those things go away, give them back to the cloud when you're done. And then ultimately, when all your processing is done, you give back the whole thing. So the idea is, Hortonworks Data Cloud just tries to make it easier for people to spin up these workloads. And then ultimately, you do the workload, you work with your S3 data, and you give it back. In the idea of a Hive LLAP cluster, it goes and configures Hive LLAP. It's ready for JDBC access. It also includes Zeppelin, so you can do your Hive queries from Zeppelin notebook UI. It also puts a protected gateway around the cluster, so that's one layer of security there. So at least we're trying to give you protection around the cluster of all its resources. So we make sure that you can access the resources from one single protected point, SSL protected, authentication protected, and then you go and access Hive, Ambari, Zeppelin, the other cluster components through that. So with that kind of basic picture laid in place of ephemeral workloads working with S3, what we want to do is talk about how do we bring those ephemeral workloads together with data lake security. So some of the key building blocks here are Ranger, Atlas, and Knox. I'm going to invite Srikant to kind of talk about those so you get a picture of what they're there for.
Thanks, Jeff. So as Jeff mentioned here, we'll start with a picture as to what our security model at Hortonworks is. We were looking at multiple levels of security around our little Hadoop elephant that's in this castle, and we have different layers of protection that we're building around it. So outside in, anything that you do, you need to start with network segmentation and firewalls. You want to be able to firewall off your network and protect your network, set up maybe VPCs that are trusted, et cetera, in this context. Once you have that, you also want to guard your entry points into your castle. So you have those drawbridges out in front. That will be Apache Knox that authorizes, from a gateway perspective, the different traffic that's coming in, whether it's API or UI requests. At the front door, you have your soldiers who are checking your passports or visas to get into the castle. So that's your LDAP and AD that does your authentication. And all around the castle, you have your watchtowers, which is Apache Ranger, authorizing who's coming, who's going, what kind of audit events, who's accessing what, and on the audit events around that. So that's kind of the picture there. And then in the future, we will also have Kerberized and wire encryption added to this HTC context. Kerberization for mutual and strong authentication between the services, and wire encryption for SSL within the services themselves. There's also the notion of the high hard walls around the castle, so that is your encryption. So we have two flavors. We have the HDFS encryption, and we also have Amazon's native SSE or server-side encryptions, which will be added in one of the future releases in HTC. So outside in, let's look at the security model. So starting with the network layer and the gateway layer, we have Apache Knox, which is a project we incubated several years ago. It's a top-level project and provides three basic areas of services: proxying services to provide access as a trusted proxy to different HTTP resources in the cluster, and as a trusted proxy for several Hadoop services that are running within the cluster. Knox also provides several types of authentication, REST API and web SSO flows. Across the Hadoop stack today, for authentication for SSO purposes, Knox is going to be the solution that works across multiple components. In the HTTP stack today, we have enabled SSO for Ambari, Ranger, and Atlas, and we'll be adding all of the other UIs, so we will have seamless SSO flows between those. And today, we support SAML v2, and we also have the capability to support OAuth, which will be added in the upcoming releases. LDAP and AD for authentication, and also Knox supports cookie-based and header pre-authentication modes. Knox also has capabilities around scripting and being able to provide token-based authentication that we are currently building, which will also go into HTC and also to HTTP on-prem. Okay. The watchtowers around the castle, Apache Ranger, is our comprehensive and extensible security console, and that provides authorization across different components amongst the ecosystem components that we have today. Ranger has the highest coverage, and you can see all of those that it authorizes from user, group, and environment and context perspective. Ranger is based on what we call an ABAC or attribute-based access control model, which is far more flexible than an RBAC or role-based model, and it helps you make a decision on for an authorization or access request based on not only the user and the group and the user context, but also the environment context. For example, what IP is this request coming from, what time of day it is, and a lot of other environmental variables and system variables that can be consulted at runtime to make that decision in a fine-grained manner. So, definitely Ranger is going to become an underpinning for us in terms of all of our security models to be able to authorize the users appropriately, and we'll show how when we run into the demo. Ranger also provides centralized auditing. So it logs every single access request for every single user and group, and also captures a lot of event-level metadata around the request itself. For example, what IP did it come from, what kind of classification was attached to the asset, et cetera. And all of that you get in a nice console that's indexed. We will see that when we look at the demo. And there's also real-time visual query interface that you can run queries on. So this is an easy way for you to show your auditors and compliance folks who touched what assets and when, and what is the request context around that in terms of IP addresses, et cetera, to be able to do some forensic analysis on that. Ranger also provides fine-grained authorization. So we have, for all of the services, for example, you could write policies that are very, very specific to a resource. In the case of HDFS, it could be a file or a folder. In case of Hive, it could be a database, table, or column. In the case of Storm, it could be a topology. In the case of Knox, it could be a topology. In the case of Atlas, it'll be who's authorized to do what operations within Atlas. In the case of Yarn, it's queues, et cetera. So very, very fine-grained model that is predicated on the type of service and the types of resources that particular service within Hadoop offers. Okay, so in the last platform release that went out back in last fall around August, we added some advanced security capabilities in Ranger. So these are primarily around the integration with Atlas, which we'll also talk about next, for tag or classification-based security, and also prohibition, time, and location-based security policies. In addition, we also added dynamic column masking and row filtering, and we'll see some examples of that when we run through the demo. These capabilities have been around for the past couple of platform releases. These went out in Ranger 0.6, and today we are at Ranger 0.7 with the HTTP 2.6 platform. So these have been around for a while and in production at several Hortonworks customers. Shifting gears a little bit, we also want to talk about Atlas, which you would have seen some announcements yesterday coming between IBM and Hortonworks in terms of a partnership and in terms of being able to expand this community. So Atlas is going to be the foundation for our unified governance story across HTTP, and also extending that beyond the Hadoop ecosystem as an open metadata platform. Today, Atlas provides these services that you see listed out there. So Atlas is a project that we incubated about 2 or 3 years ago with a bunch of industry leaders in different verticals, and that has now matured, and we've had several platform releases to provide some of these foundational capabilities that you see here, which we'll be enhancing in the future to include full-blown governance, full-blown lineage, and open metadata exchange with other platforms outside of Hadoop. Today, what Atlas offers is data lineage and provenance. This is across different components that you see out there on the left, for example, for Kafka, Hive, Storm, Falcon, and Scoop. And data classification, which is the ability to match business terms or attach different types of business contact information to your data, and also help you classify and add attributes to data so you can process and write security policies or take other actions based on that in terms of your physical assets. Atlas is also a large metadata catalog, so every single asset that exists in Hadoop can be indexed, and you can see all the metadata about all of those assets. It's queryable interface and very feature-rich SQL-like interface called DSL that's available along with simple search. We'll see that when we look at the demo. And then also provides a very robust type system that lets you model any type of objects, and out-of-the-box integrations for several items. Everything that you see here on this slide is available out in the open We have full RESTful APIs with documentation around this. And the last piece, which is the critical piece we added in HTTP 2.5, is Ranger and Atlas integration piece, which is whatever classifications that you do in Atlas will flow seamlessly into Ranger and are available near real time for you to author security policies and enforce in near real time on the component sites for the services that are authorized. So we'll see an example of that when we run through Atlas. So basic benefits here is that we want to make sure that you have your cost envelope when you have this big data environments doesn't go up to, and you don't have to scale your teams to be able to manage those, be able to handle different types of data sets, and also do these very quickly in these fast-changing big data environments. We'll probably cover this when we look through the demo, but these are the variety of policies that the Atlas and Ranger integration enable. So you can have classification-based policies, prohibition-based policies, which help you prevent toxic joins of different data sets, different parts of a data set. Time and location-based policies, for example, you could write very precise policies that say, do not allow your offshore team to access a specific piece of data outside of their business hours. So that has a semblance of geolocation or geofencing along with the time of the request to make the determination in addition to the user and the user context in which that request is coming in. So we'll show all of this when we run through the demo. So I'll now hand it back to Jeff so he can talk through how we set up this in the HTC environment.
Cool. Is this the only session that said toxic joins? Yeah, it's a good one. So with the building blocks of Ranger, Atlas, Knox kind of there for security and governance, and with the idea in the cloud that you can take advantage of cloud storage that's always there with your data, and the ephemeral workloads come along and they come and go as you're doing your processing only, we kind of stepped back and said, how do we introduce the idea of bringing together things that have to be there all the time when your workloads aren't? The storage is always there. OK, cloud storage, check. But where do my security policies come from? Where do users and groups for authorization authentication come from? How do I define the schema around data? So if I'm doing SQL queries, how do I set up the schema that I'm actually going to work against that are going to be enforced by the policies that are there? So we kind of looked at it as a journey here. So in the basic and advanced cases, when you're running ephemeral workloads in the cloud, it's really about, hey, let me make sure I can get infrastructure really quick that's tuned and optimized for a workload. Let me make sure it works well with cloud storage. Let me protect it with a gateway. Those are kind of like all table stakes. And then the idea that you could do just really kind of run this workload, this user gets his work done, and kind of you're done with the resources is great. You can kind of build up from there. And in the middle tier, the advanced is about, let me make sure that at least I always have consistent and reused schema around that data, so I don't have to rebuild the schema each time or have inconsistencies when workloads are running and have anything out of date. So if I need to do queries, I know the tables that are there and how things are set up. But in the enterprise ephemeral case, we're thinking about how can I actually not just get the schema that's shared, how do I do authentication with an external source like LDAP or Active Directory? How do I pick up authorization and security policies with Ranger? How do I have Ranger audit all the access there? And how do I make this all come together in a way when not everything's there all the time? So if we revisit this diagram, in the beginning, we were just talking about durable storage that's always there, workloads that are coming and going that are ephemeral. But in the middle, there's this sense of long-running things that hold on to information that you want to make sure that's always there. So when your workloads come and go, they can actually attach to those things and pick those up seamlessly. So the first one is about schema. Let's make sure the schema is there so your workloads always know what the table structure is or the structure of the data is when they want to run their queries. Let's make sure that I also have the security policies are always there and the catalog's always there that helps me enforce those policies. So when you think about putting those things in more of a long-running context with workloads coming and going that are working against durable storage, we call that kind of a set of shared data lake services. So you're going to go build a data lake, which is the combination of all these things, the storage, the workloads, but this core set of services for security, governance, and schema, let's go share those across the workloads and wrap them around the data. So some of the components there, we talked about, obviously, Ranger, Atlas, Knox, and they kind of play into here when it comes to the gateway, security policies, and audit. For schema, it's really around Hive Metastore. So let me go and make sure that that's shared as well. And then where am I going to get my users and groups so I can set up my policies against for authorization? And how are they going to authenticate? So that's really around the directory itself. So you kind of need all these pieces to be able to put that puzzle together. So everything from the schema, policy, audit, directory, and gateway. And the way we end up seeing that together from an architecture perspective from the idea of having things that are durable all the way to ephemeral, it looks like this. So end user access is through a central protected gateway. The cluster workloads are coming and going, but the shared set of data lake services are always there and available. So your workloads come, go, attach to those shared data lake services. The audit is in that central place. The policies are in that central place. The schema is always there. Authentication and authorization happens there, as well as when people go and use the workloads and execute with the workloads, we also do authentication there. So the idea is, let's go give people a way to create these shared data lake services, spin up the workloads that can attach to those things, and then make sure they run in the security context that is being set up by that set of the shared data lake services. So, what we want to do here is I'm going to jump into a demo to kind of show how we put these pieces together, and then we'll actually go deeper and show once they're all there, how does it actually look from an end user perspective and how do we enforce the policies. So to be able to set these things up, I obviously need to have an authentication source. I need a set of users and groups, so I have to register an authentication source. Because I do want to make sure the shared data lake itself is resilient, I need some things that are external, so I can leverage some things like an S3 bucket to store the audit logs, Amazon RDS for some databases where I know the security policies can be stored. And then once I have those building blocks in place, I can actually go and create this shared data lake that uses that LDAP, that uses Ranger and the Hive Metastore for authorization, audit, and schema, and then I can go attach my workload clusters to it. So I'm going to switch into a bit of a longer demo. We'll do two parts here. I'll do a first part showing some of the building blocks coming together, and then I'll switch it over to Srikanth to kind of dive in a bit more. So I'm back in Hortonworks Data Cloud. This one's actually a little bit different. I've kind of prepped it in with a couple extra things. So one, I went and registered an authentication source in this Hortonworks Data Cloud. So I went and said, hey, there's actually an LDAP directory that I have that has some users and groups in it, so I can use that as my authentication source as well as my source for groups to handle authorization. I prepped it to have a database for the Hive Metastore, so that's external from the clusters itself. And then I've actually gone and created a set of shared data lake services that has the Ranger that's leveraging all those things where I can go and actually start creating policies around it. So I've gone and actually created that thing where, some simple questions here, trying to keep it as a small footprint as possible to tie it to the AWS resources and the external resources for resiliency. Once it's spun up there and it's time to go and actually use this, when I go and actually spin up a workload now, I have a choice to say, do I want this workload to be one of those basic type workloads that doesn't actually run in the context of the shared data lake, or actually I want it to attach to that. So when it runs, it's wired up to the LDAP, it's wired up to the Ranger, it's going to audit to Ranger, and all those pieces and parts are there. So just by choosing, I want to go and attach this workload, so my Hive LLAP workload that's going to do interactive query will attach to this data lake, pick up the schema there, and the Ranger will enforce the security policies around that schema and audit all the access there. Is just through this click here. My workload can come, I can do my work, spin it down when I'm done, policies live on after that. So with these building blocks in place, I'm going to hand it over to Srikanth to show, let's see it from an end user perspective.
Thanks, Jeff. All right, so here's another similar environment. So we have two clusters here. So the first one, this is, let's say you have a bank, and let's call it Hortonia Bank for fun. So we have a couple of users here. There is an analyst group, and there is an HR group. They want to get different views into the data that's sitting in this bank's context, and they want to get different slice of the data. They want to do different types of operations on the data. So we have two ephemeral clusters here spun up, and they want to be able to also use different engines to get to that data. So in the first case, we have an ephemeral workload that is now running via Hive LLAP, and the second one that we're going to run via Spark. And then we're going to show you how, with a consistent set of policies, you can get the same enforcement independent of the engine in different clusters. So you define your security policies in one place. They will get at runtime applied to these different cluster contexts and to the different user contexts, and you'll see how all of that kind of comes together. So let's first go look at what the analyst picture is. So here's an analyst sitting in Hortonia Bank who wants to run some analytics around what is the let's say, the incidence of obesity across different zip codes. So he's trying to run some very basic analytics on that. Now he goes and runs this paragraph here. So all we're doing is a very simple JDBC Spark query into this that goes through Spark SQL and Hive LLAP, and that will present those data back to you. So this user has now run a query that went in from via the Spark JDBC drivers into Spark SQL, and then hit Hive, and then the queries got filtered with the policies that you have in Ranger in the background. So we'll see what happened here. Let's go shift into Ranger here. Ranger has very extensive auditing. So you'll see that there's a bunch of events here, and there are several security policies as well as a lot of event metadata. So you click on this, you'll know what type of policy it is. So in this case, there's a simple policy here that says for US employees, they can access the US customers table. And that's what he was trying to access to get that chart that you saw there. Ranger has authorization for several services. Notice how each of these, you can write policies for each of these services, and they have their own policy repository. And in this case, we've only turned on Hive and Atlas. So you can go look at some of these Hive policies. Under Hive policies, you can write very, very granular policies at a database table or column level. And you can also apply masking or dynamic masking on the way out. So you can present different views of the same data to different users. We'll see how we do that. And then we can also have row filtering policies, which let you dynamically filter different contexts and get you out of the business of managing different views and authorizations around those views. So you define this policy once, and then it gets applied runtime. So if you had like 50 different groups which need to have different views, you can just kind of dynamically insert a predicate that will get inserted into the query and filtered every time, so you don't have to manage those 50 views. It'll get enforced at runtime based on the filter that you apply. So let's just take a very quick look here. I want to show you one interesting policy. So in this case, the bank has a policy to say the analysts should not be joining in any context the zip code with other pieces of data, other pieces of PII data. So what you see here is this, on this table, the customers table, there's a zip code field, and you cannot join that with a medical record number or with the blood type, because that will end up re-identifying that individual. So we want to be able to precisely prevent the toxic combination of these joins. And then you can define them at whatever granularity that you want and have that be seamlessly enforced in this context. Okay, so let's see how that works down here. I'm going to shift to the paragraph at the bottom here. So now the same analyst who's now prohibited from joining this tried to do this join, and he's blocked. And if you go into the Ranger audit event, you will see that this analyst got blocked, and you can see which policy blocked him. So this is the prohibition policy that we just looked at, and we capture all kinds of metadata around the event itself, who's the user, what resources they tried to access, what is the time of the request, what IP address, and whether there's any classifications attached to that particular column that he was trying to access. Okay, so Ranger also has the capability to do masking policies. In this case, the bank has got some policies to say analysts cannot see the data in the clear. So we run a query that against the same customer table. The analyst is running this query, and he sees a bunch of things that will be masked. So I think I have a login issue here. Let's see. All right, so in any case, if you run this, we'll see the audit events here. So you see all of these masking policies got applied. We can look at the masking policy that specifically allowed this case. So let's go back here into the policies, and I'll show you some examples of that. These masking policies are very simple to set up. You pick the database table and column, and then the user or group that you want to show masked, and then the different types of masking that are available. So we have redaction, partial masking, the first four, last four, etc. And then we also provide a custom masking option, which means you can insert any kind of valid Hive to UDF in there that will return the same type as the column. So for example, you started with a string, you end up with a string. So any of those masking functions are going to be inserted here, so you can roll your own masking function if you wanted more sophisticated masking here. Also, in Ranger, we support row filtering policies. So here's an example. So the intent of this policy is to say, instead of managing multiple views for different groups, there's commingled data in this bank in a Hive table, which has data rows corresponding to different customers from different geographies, some from EU, some from US. So when EU personnel access that table and they do a select star, they need to be able to only see the rows corresponding to the EU customers. And the US personnel, when they run the queries, they need to only see the US customers' data. And without this capability, you'll have to manage multiple views for these and have to manage authorizations around this. Instead, we have a very simple policy condition that you can insert to say, for the US employee group, just allow them to see the data when the customer's location is the US. And in the case of EU employees, we can actually go do a lookup into another reference table which says which countries are in the EU, because that's changing quite rapidly with Brexit, et cetera. So dynamically, you can enforce the policies based on those conditions. So now in this case, let's see what happens when the analyst runs. This is the HR analyst. She's running this to say what is the country of origin for some of these customers. And you will see the policies being enforced here. Let's go back into audits, and then I can show you the audit events that correspond to this. So you can see that this HR analyst, when they try to run this, the row filtering policy that we just looked at got enforced dynamically. So in this way, with the setup that Jeff outlined, in that shared data lake environment, you can have your data externalized in S3 and have a centralized policy that gets applied across all of the ephemeral workloads that go against that whole constellation of clusters, and have complete auditing and complete security policies and control over that. So we've shown how we can stitch together this picture all the way from the outside, from the Knox gateway, which protects the access from outside, to very detailed auditing and a way to manage all these security policies seamlessly in one environment using Ranger. The same things that you would apply in your on-prem HTTP clusters are now available seamlessly in the cloud and now available across a central kind of repository. So this point will shift back to the slides here. So what are some guidelines for how do we use this shared data lake services? So we want to keep the workloads ephemeral and the data permanent. So you want to keep that in a resilient store, as Jeff pointed out, so S3 or RDS. S3 in this case is used for audits and for the actual data for your Hive tables. RDS is used for the Hive Metastore and also for the Ranger policies. Do not create that files or tables in the local HDFS, because the local HDFS is not used here at all. All of the data is externalized in the first-class Amazon services that are provided there. The Hive warehouse is set out to be based on S3 for those data lakes, and then create those as external tables. Because your data is external and you don't want to pull any of this into the ephemeral clusters, you'd want to keep that permanent and have that be operational beyond the life of a particular cluster. So use those external tables when you're in this environment, and then set up the S3 bucket policies to have the minimal set and the minimal set of privileges, so that you can put all of the other layering in terms of column level security and all of the dynamic security that we looked at via Ranger. So do the minimum that you need on the IAM systems for the S3 bucket policies, and have all of the runtime and dynamic enforcement delegated to Ranger, and the security at the perimeter delegated to Knox, which will give you full protection end-to-end for all of this data. So with that, I will shift it back to Jeff, who will do the wrap-up.
All right, cool. So in the last couple of minutes here, just some things to take away. So as we've kind of gone on the journey, talking with a lot of customers over the past couple of years, we've seen, obviously the agility and flexibility of cloud. We want to take advantage of that. So, think about more and more ephemeral type data processing, so that you get the benefit there of that flexibility. And then think about cloud storage a lot as more durable storage, since those workloads are coming and going. And this kind of brought us to see this pattern emerge for shared data lake services, the longer running idea, the policy security policy, schema, and audit always being available. And then we want to make sure that that's there to kind of hit the AAA, the authentication, authorization, and audit, so that you can share them across those workloads. So think workloads, deploy what you need to get the work done. Hive LDAP for interactive query, Spark and Zeppelin for data science. Could be traditional Hive for more ETL type data cleansing and prep. So right tool, right job, just run it when you want to, think about that workload. And then do it more ephemerally, so when you need it, run it, workloads come and go. So use the resources and give them back when you're done. And then think about sharing. You know, the idea of that the security policies are shared, schema is shared, and then you have that end-to-end security for your workloads. And as your users are accessing those workloads, they run in that security context and have that consistent experience for how those policies are enforced. So with all of that, there's a couple other places to go try some stuff. So you can try out Hortonworks Data Cloud. You can try out ephemeral workloads working with S3 data. You can try out some of the shared services. So you can go check that out. So the stuff we showed here, you can go try. There's another breakout session this afternoon that Srikanth is doing. Yep, so you can go and check that out, and they'll talk specifically about Spark and securing Spark there. There's a crash course on Thursday, so tomorrow, that digs into Spark and Hive, just in general about doing processing on the cloud, so that would be a great one to go and check out. And then there's also the birds of the feather tomorrow, so security and governance and cloud and operations. You have to flip a coin, see which one you want to go to, since they conflict, but maybe you'll be able to go to one, go to the next one after that. But cool, kind of with that, want to thank everybody. I think we have a couple minutes for some questions. So we'll take those now before they kind of turn the mics off on us. Question down here in front.
So in that demo you showed us, where was Knox and Ranger running?
Okay, so the question was, in the demo, where was Knox and Ranger running? So the Ranger itself is running in the shared data lake, so it's running on that node that's kind of always on with Ranger. The Knox itself is running around the workload cluster. So when you spin up the workload, we wrap Knox around it so that when people go to access that workload, it's protected at that point. So we put Knox in the actual workload cluster, and we put Ranger in the shared data lake there.
And then the policies are stored in RDS?
In RDS for Ranger, correct. Okay. Yep. So then the idea is that the shared data lake could be brought up and down, but we still have the policies that are available in RDS, so we can reattach even in that case there.
And if you move it to, let's say, a different shared lake environment, you still have your policies available in the cloud, so you can migrate those over.
Yep. Cool.
Okay.
Do you support Kerberos as well as LDAP?
So we don't support Kerberos today in the HTC environment, but that's coming. So, yeah.
Can example work on cloud storage?
Hello.
Yeah, sure.
Yeah, so in Azure, our story is around HD Insights and the co-branded offering with Microsoft. And over there, Ranger has already been turned on. So it's available in, yeah. So, but HDP on Azure, you should be able to get all of the features that you get there.
Yep. So to add there, HDP itself has support for working with S3, WASB, or ADLS directly. And then with HDI, we have the Ranger integration, but you could also use HDP directly with ADLS and have your Ranger and Atlas there too. So it's a different combination depending on your choice of a PaaS or an IaaS type cloud solution. And we're seeing a mix kind of there as we talk to more people.
Yeah, and we do have, for example, in the Azure environment, we have Ranger plugins that we've built with Microsoft for WASP. So we'll be talking a little bit about it in the partner session coming up later in the day. There.
Sorry, go ahead.
Go ahead.
Correct. Yeah. So no integration with EMR. I think EMR kind of leaves you at a point of getting access to the Apache project. But then if you want to actually wire in the Ranger and kind of create this, it's kind of up to you right now. We kind of looked at it as, let's take it from the top down, from the workload and the security context down. So we kind of said, this is a pattern to do it there, where EMR kind of brings you up to the workload and leaves the rest to you.
So one question. One of the things we are hearing is with Hive LLAP, you can point your BI tools to Hive directly. But does that mean that you have to have your cluster running all the time? Because if it's just on S3 and your cluster is not running, you can't pull it from BI, the information?
So the question is Hive LLAP and kind of long running versus ephemeral. You might find that with Hive LDAP, you might run longer than just hours type scenario to actually get the benefit there. And so we should clarify with cloud, you will run more ephemeral workloads, but there still might be cases for longer running clusters, but you actually tune them down when you're not using them and tune them back up. So you actually there you go with more flexible clusters that are long living versus just purely ephemeral there. So there's, it's kind of going to depend on what's the workload look like to make that decision there.
Okay.
Oh, sorry.
We can. Hive was running in both places. So the analyst was using Spark, and the HR analyst, she was using just Hive JDBC. So Hive LLAP is running in both the places. In one case, you're using Spark. In the other case, you're going straight to Hive.
Yep. It's in both ephemeral clusters, not the long running ones.
It's not, Hive is not running in the shared lake cluster. It's only running in the ephemeral clusters.
Yep. Cool. I think they're pulling the plug on us. We're going to hang out for a bit
Yeah.
and answer more questions there. I want to thank everybody, so come on
Thank
up.
you.
Cool. Cheers.